with what to do if we have an exponential equation to start. Yeah. Yes. Yes. All right, so let's just look at this page here. So there's really going to be three approaches that we're going to take, okay? If you can make the base the same, which, as you can see, we really... Actually, this one we might be able to do, but we're going to do that because that's easier. You don't have to use logs. You can just make it the same base and then figure it out from there. If you cannot make it the same base, then we do something a little bit different. We just switch it to log form, and then we do what we've been doing. So let's start with A. What base is 4, really? 2. What about 32? That is also base 2. Okay, so for this one, 4 would be the same thing as 2 squared. 32 is 2 to the 5th. So 2x has to be 5, and x is then 5 over 2. Here?
Yeah.
Well, yeah, I do. I just kind of skipped that step. 2 times x is just 2x, so. Two and x, if you multiply them, it's just 2x. I'm not sure where you're getting 4.
What about the...
Okay.
No, he turned it back to the 4. That's why. He used 2 squared.
Oh, right. Yeah. Okay. Are you okay, David?
Yeah.
Okay. Maybe. Let's go on to B. First of all, can we reduce 9/27ths?
Yeah.
What is that?
What did you just say? You said 1/3. No, I used that. I sounded like something different.
I was like, I thought that was a good idea.
No, I heard her say someone said something else and it's combined in
Okay.
my head. I'm sorry.
So this is base 3 clearly. Can we write this so it's base 3? 3 to the -1. Now you set these equal. Again, these are ones that we know how to solve already. So now we're going to add. X is going to be 0. Okay? Makes sense so far?
Yes.
Okay. This one. First, we have all different bases, 2, 3, and 5. You can't make any of those the same base. Okay? So now what we want to do is isolate the part where we have the exponent. So what can we do first? Divide by 2. So over here, 5 divided by 2 is 5 over 2, or 2.5, right? And now, that's 2.5. Here's where we need to use logs now. So we don't have a way of making these the same base, but we can switch it to log form and go from there. So what would this be in log form? Of equals. Good. Okay, and you know what? One more step and we're done. Divided by 4. So this is log base 3 of 2.5 over 4. And you should be able to type that into the calculator if you need to get an approximation. So let's do that real quick. Okay. So if you forgot, you press alpha And really, it's the second button right here. And there's your log base function. And you just type in log base 3, 2.5. We want to do that divided by 4. And so our approximation is about 0.21 or so. Okay? Now, do you guys know how to check your answer to make sure you did it right? Plug it back in. That's a lot of things to plug back in, right?
Yeah.
How can we, have we talked about storing?
I think you
Mentioned it? Okay. So here's what we can do down here. You see this STO button? Okay, that stands for store. So if you take your answer and take that and just press store, this little thing pops up. It's asking you, what do you want me to do with this answer? And you're going to tell it, you know what, let's make that X. Okay? If you hit enter, it just gives you the same decimals again, but now it's registered that X and this decimal are the same value. And so now what you can do is you go back to the original equation, type in the left-hand side. So 2 times 3 to the, and I would literally type in 4x instead of typing in all the decimals. And what do we get? 5, which is exactly what needs to happen. Okay? Yes?
Can you still print all the decimals?
You still could.
Right.
Sure. But that, yeah, it takes a little bit of time.
Would
If
you
you
get the same answer if you would put all decimals on?
2 times 3 to the, I can't believe you guys are making me do this.
I'm just saying.
4 times, let's see, 0.208, 519. Nope, I screwed up already. 208, 510, 9418.
You all asked for too much.
Okay, the thing is though, you could even have guessed, or not guessed, but figured out that you got the answer right, even if you didn't type in all the decimals. Let's say you just did the first 4. What does this tell us? It's pretty much 5, right? Since we're cutting off all those decimals and we're getting really darn close to 5, this is probably correct. Okay. All right.
How do you get rid of the X that's stored as that value?
You just override it when you need it to be something else.
How do you,
So like if I wanted to store 23 into X, you just type in 23, store X, and now every time you press X, it'll be 23. Does that make sense? Yeah, you just change it as you need it.
like in the Y equals menu? Or,
Oh, good question. It does not affect the Y equals menu. Like when you go to the Y equals menu, it knows X is a variable, not a specific value. I see what you're saying. Yeah, don't have to worry about that. I will show you. There's regular 2x, not 23. Okay? Or in this case, it'd be 46. But okay. Next one. Can we get the same base? So let's just go ahead and write it in log form, since the exponential is already alone. Log base e of equals x minus 1. Log base e is the same as natural log of 8. And we could just add 1 to the other side. And there we are. Okay? You cannot add 1 to 8 because there's that ln in the way. If it helps you to remember, put parentheses around what you have in a log. That way you never think of doing that. Yes?
What was like minus L and 1 and we can find the 2 together, right? Because if it was like X minus L and 1.
Oh, and then we had like ln 8 minus ln. Yes, then you can put them together.
Okay.
Exactly.
Also, can you put log E or it has to be natural?
I will accept log base e. Yes. But you should know
Same.
it's the same thing because you might see a multiple choice question where it's like, here are your options. And if you're like, but darn it, it's log base e, and your choices are ln or, you got to register that it's the same. Okay? Any questions on this?
You only put L on once to E.
Yeah, when that's the base, log base e. Okay. So now, here's where it gets a little bit trickier, okay? These equations up here had an exponent just attached to one thing, right? X was only part of one exponent. Down here, we see this exponent has an x and this one does too. So that creates a problem. For example, if I said, let's put this in log form, and I asked you, okay, what would it be? Log base what? But why not base 3? Aren't they both the base? Do you see what I'm saying? If this did not have an exponent, then I would clearly agree, log base 4 makes sense. Since these both have exponents, okay, here's the process. We're going to start by taking the log of both sides. Doesn't matter what log you take. It could be natural log. It could be log base 10. Since we have these buttons readily available on the calculator, log and natural log, I would recommend doing one of those. Okay? And since I'm lazy, and I don't want to write log because that's one more character than ln, I'm going to take ln of both sides. Okay. So now, the point of doing this is once you get here, we have exponent properties that tell us that we can bring this exponent where? Where can we put this exponent instead of on the inside? Outside in front of the log, right? So this is the same as x times natural log 4. And then over here we can do the same thing. Bring the exponent out in front. Okay? Does that make sense so far? Okay? And then now, I know this looks goofy, like natural log of 3, right? But that's just really, it's just a number. If we had a normal number out here, like let's just say 3, what would we do with that? If this were just a 3, what would I do with this? Well, if it's multiplying it, you could divide by it or you can distribute it in, right? So that's actually a pretty good move, is to distribute. So this natural log of 3 gets distributed to both terms. And now we have 2x times natural log of 3 plus 1 times natural log of 3 is natural log of 3. Sorry, I'm switching to cursive on you. Yes?
Say you were to divide could you do that?
You could, but it would actually make it more work, and you'll see why in a minute. Okay? So now that we have this, you want to get the terms that have an x together on the same side. Okay? So I'm going to move 2x natural log of 3 to the left and keep natural log of 3 on the right. You guys see what I'm doing there? Okay? And now, since we have x as common to both terms, okay, we can factor this x out. Let me just continue it up here. If I factor x out, what's left? ln 4 minus 2 ln 3, and that all equals ln, or natural log of 3. And now we're almost done. We just have one last thing to do. X times this stuff, how do I get rid of it? You divide by it. So your final answer is going to be x equals natural log of 3 all over natural log of 4 minus 2 natural log 3. Okay? If you had done this using a different base log, let's say regular log, instead of ln, we're using log base 10, right? What's the only thing that changes? Yeah, instead of natural log here, it'll just be log 3, log 4, minus 2 log 3. It's the same process, same answer. You can pick whatever base you want to use, though. Okay? Does that make sense, you guys?
Why is it more complicated?
Let's take a look. So let's say, I'm not going to do this one anyway, but let's say I did the other option. So x ln 4 equals 2x plus 1, and then that equals, or times natural log of 3, right? So if we divide by natural log of 3, now we have x ln 4 over ln 3 equals 2x plus 1. Now what?
I think yesterday you said you can just cross out the.
Yeah, no. You can't just do that and say it's 4x over 3. Is that what you were thinking?
Maybe.
So that, do you see how it's getting more complicated already? If you actually wanted to finish this, you'd have to go subtract 2x, because you want the x's on the same side. You'd still factor out the x. And then you'd have 1 over natural log of 4 over natural log of 3 minus 2. But then we have to simplify that. We don't want complex fractions, right? Remember when we did complex fractions, we can get rid of this little denominator by doing what? Multiplying by it. So if I multiply by ln 3 up here, guess what I get? Natural log 3. Here it cancels and we just get, do you see what I'm saying?
I got it.
Yeah.
I'm still doing that.
Do it the other way?
Yeah.
Good idea. All right. These are all the same pretty much, you guys. So I'm not going to do those examples. Okay? Do you guys have any questions?
No.
Not as of yet. Okay.
Yeah,
Let's go to the last page. We're going to skip this section entirely. Don't worry about it. So this is the last thing we need to talk about, which we've kind of, I think we talked about the calculator a little bit yesterday, right? But let's just review, okay? Using the calculator to solve equations like this, okay? So let's take a look at part A. If I go to the y equals menu, what do I do? Left-hand side, very good, goes into y1, so that'll be e to the x. And on the right-hand side, it's just 1 over 11 times x squared. We did do this yesterday, right?
No. It's the bottom of that page.
Well, good thing we're reviewing it, okay? So we graph the left-hand side, we graph the right-hand side. Let's see what happens. Here's e to the x. And there is 1/11 x squared. Looks like there's an intersection over here somewhere, right? How do I find that intersection? Second, trace, and then you use the intersect feature. That's correct. So you go to intersect. We're only graphing two curves, so if you automatically hit enter twice in a row, it changes or it switches from y1 to y2, which is what we want to do. And now for the guess, you just get it over there somewhere reasonably close, and there's our approximate solution right here. Okay, so here we would say x is approximately 1 point. Let's do. Oh, thanks, guys. Negative 1.54. That's it. Okay.
You don't need y.
No, because this is just. So this is a good thing to know, though. This y value would be what you would get on each side of the equation if you were to actually plug everything in. So you know how we said let's check to see if this works? If you take this value and plug it in here, you're going to get approximately 0.2149. And if you take that and plug it into the right side, you're also going to get 0.2149. Does that make sense? Okay.